Hello everyone, welcome to Scholar Lab. Our simulations can transform your teaching approach, making lessons much more interactive and captivating for your students. Scholar Lab is a distinctive virtual laboratory that brings intricate STEM concepts to life through engaging simulations. This tool is crafted to aid students in comprehending and applying scientific principles in practical situations. Today, we are embarking on an exciting journey into the world of organic chemistry. We are going to specifically focus on identifying organic functional groups. Let's get started and bring the fascinating world of organic chemistry to life in your classrooms. Let me open organic functional group simulation for you. Each simulation begins with a game plan that outlines the procedures, observations, and learnings. I recommend that new users to go through this section thoroughly to maximize their experience. The main objective of this simulation is to test the presence of various organic functional groups like alcohol, aldehydes, ketones, carboxylic acids, nitrogen containing compounds, and etc. by using their standard test. Also, in the Playground tab, you will get an opportunity to become a millionaire by testing Grandma's Magic Cleaner for its ingredients. Let's get started. Let me close this game plan. Our simulation offers various views by click, hold and dragging the mouse button. Also, you can make use of this right hand side bottom button to view our simulation in different angles. F for front view, R for right, L for left and T for top. Also, you can make use of this slider which is on the left hand side of your screen to zoom in and zoom out in the simulation. By using this tag button, you can show or hide the labels. I'll show you in detail in a while. In this simulation, we have structured our exploration into three main parts: concept, playground, and quiz. This step-by-step approach will help your students to understand the methods used to identify various functional groups. Under concept, we have the test for unsaturation and test to identify functional group. Let me show you test for unsaturation first. Here we have two solutions. The one is saturated, another one is unsaturated, which are named A and B respectively. And also we have bromine water. By clicking on bromine water, it gets added to test tube A, which is saturated. By clicking on the test tube, it is shaking it well and observe the color change. There is no color change happen in test tube A, which clearly indicates that the solution is saturated. Now click on the bromine water. It will get added to test tube B, which contains unsaturated solution. Upon shaking, it decolorizes, which shows that the sample is unsaturated. A similar experiment can be conducted with Bayes test also. Here we have Bayes solution, that is alkaline KMnO4. Let me add that by clicking on it to saturated and unsaturated solution. If the purple color persists, the sample is saturated, and if the purple color disappears, it indicates that the sample is unsaturated. As a second part of the concept, we have the test for functional group. Here we have list of organic functional group like alcohol, phenol, aldehyde, ketone, carboxylic acid and amines. Let's do one by one. For alcohol, we have these many tests to perform. Let's start with sodium metal test. By clicking on the spatula, calcium sulfate, which will get added to the sample A, and upon clicking on it, it will get mixed. To remove the excess water, let me filter out to the another clean test tube, which is B. Now it's time to add sodium metal. By using forceps, I'm adding sodium metal to the test tube B. Now you can use your zoom in slider or the mouse to zoom in and view the bubbles coming out from the test tube, which shows the presence of alcohol. These bubbles are nothing but alcohol is reacting with sodium metal to give hydrogen gas. Let's go to the next part for alcohol, that is ester test. Here we have glacial acetic acid, concentrated sulfuric acid to be tested with or reacted with alcohol. Let me click on glacial acetic acid. And to maintain acidic medium, we are adding a drop of concentrated sulfuric acid. I'm keeping it in hot water bath for 10 minutes, but since we have a time lapse in our simulation, we need not to wait for 10 minutes. We just need to wait for 10 seconds only. Now you can see the fruity odor is confirmed, which confirms the presence of alcohol functional group. Let's go to the third part for the alcohol tests, that is cetic ammonium nitrate test. With one click, we'll add the reagent to the alcohol. The vibrant lead color shows the presence of alcohol, as you can see here. Let's move on to acetyl chloride test. Let's begin by adding calcium sulfate by using the spatula, and let me mix that to get rid of the excess water, and also by clicking on it, it will get transformed to the another clean test tube. Now I'm going to add acetyl chloride to it, and the main part is we are going to introduce a glass rod dipped in ammonium hydroxide. Let's see what happens. Watch closely. A cloud of white fumes are coming from the test tube B, which indicates it's the presence of alcohol functional group. For the more conclusive test for alcohol, here we have iodoform test. For that, we are using 1% iodine solution, and for maintaining the alkaline medium, we have dilute sodium hydroxide also. Let me add that by clicking on it. Now I'm going to place this mixture in the hot water bath for a while. Look, yellow precipitate is forming, which confirms the presence of alcohol here. This test is important in both theoretical and practical organic chemistry also. Let's differentiate between primary, secondary, tertiary alcohols using Lucas reagent, which is anhydrous zinc chloride with dilute HCl. To each type of alcohol, we have a separate test tube, C for primary, B for secondary, and A for tertiary. and we have Lucas reagent also. Let's add Lucas reagent to tertiary alcohol. I hope you can see the turbidity appear immediately for tertiary alcohol. Let's add Lucas reagent to B, which is secondary alcohol. The immediate turbidity is not appearing, but still, while shaking on the test tube, it should show the turbidity. Yes. Let's try out for primary alcohol also. The turbidity is not appearing now also, so let me heat it. Yes, great. So it shows that the alcohol functional group, which is separated as primary, secondary and tertiary, which is clearly explained using Lucas test. Let's go to the second major functional group, that is phenol. Phenol is nothing but aromatic ring, basically the benzene, which is having alcohol functional group in it. You can start with litmus test also by using the litmus paper. And let me show you ferric chloride test. By adding neutral ferric chloride, it should show the purple color which confirms the presence of phenol. Let's go to a bit stronger. Let's go to Lieberman nitroso test. Here we have concentrated sulfuric acid, water and sodium hydroxide. Let's see what the color change will be observed for each one of these reagents are added to the test tube. So here we have a sample in a test tube A. Let's add sodium nitrite and shake it well. Let me add concentrated sulfuric acid. Keep an eye on the color. It turns blue due to the formation of iodophenol. If phenol is present, if I am going to dilute it with water, and you can see the difference in color also. Yes, it's changing the color to red. Let's do it with sodium hydroxide solution. Finally, by adding sodium hydroxide, it results in a blue or green color solution which are forming the phenol's presence. The next test for phenol is that Thallium dye test. When phenol is heated with phthalic anhydride, in the presence of concentrated sulfuric acid, it forms phenolphthalein. Upon reacting with sodium hydroxide, phenolphthalein gives vibrant pink color. Let's test it. Great. So it confirms the presence of phenol in the given sample. Let's go to the next functional group, that is aldehyde. Under this, we have very important test, that is shift test, Tollens, Fellings, 2,4-DNP and sodium bisulfate test. Let's explore one by one in detail. Let's go to shift test. Let me add the reagent to the sample. If aldehyde is present, the characteristic magenta color will develop, which clearly indicates the presence of aldehyde. Let's go to the next test for aldehyde, that is Tollens test. Usually in the lab, students will struggle to get the silver mirror in case of Tollens test. Let's show them clearly how the silver mirror will appear. And what are the conditions to be maintained to get the silver mirror? Let's start by adding silver nitrate to the test tube. For making it basic, I'm adding dilute sodium hydroxide and ammonia solution. The tolerance reagent, which is the basic media of silver nitrate with ammonia solution, right? So let's add sample to it, which is nothing but aldehyde. Let's keep it for water bath for a few minutes. You can clearly see the silver mirror appears on the test tube, which is a proof of the presence of alcohol functional group. Let's go to one more interesting test for testing the presence of aldehyde group, which is Phenols test. Here we have Phenols solution A and Phenols solution B. Phenol A, as we all know, that is copper sulfate, pentahydrate, and Phenols B, which is sodium potassium tartrate. Let's add one by one to the test tube. When I'm keeping it in a hard water bath, it should turn red color because of the presence of cuprous oxide. Yes, great. Let's move on to the next test for aldehyde, that is 2,4 DNP test. Here we have alcohol that is mentioned as rectified spirit and 2,4 DNP also present over here. Let's add one by one to the sample. It should produce a bright yellow to orange crystalline solids, which are nothing but hydrozones. And finally, in aldehyde, we have sodium bisulfite test. Here we have sodium bisulfate, which is added to the test tube with just a single click. And I'm going to close it using a cork and shaking it well. Usually this white precipitate will form after 15 to 20 minutes, but we need not to wait for 15 to 20 minutes to get this white precipitate, because we are using simulation to perform the experiment. We have wonderful feature of time lapse here. Let's go to another carbonyl group, that is ketone. Here we have two important tests to confirm the presence of ketone, because we know that aldehyde and ketone which will go positive for many of those tests. So particularly for ketone, we have metadinitrobenzene test and sodium nitroprusside test. Let's start with metadinitrobenzene test. Let me add it using spatula and shaking it well by adding sodium hydroxide. The violet color disappears after a few minutes, which indicates the ketone group in the sample. As the next part of ketone, we have sodium nitroprusside test. Let's add it to the sample of the test tube A. After adding sodium nitroprusside, we are going to shake it well, and then I'm going to add sodium hydroxide dropwise. If a red color appears, yes, there is the presence of ketone functional group is confirmed. Let's go to the very important functional group, that is carboxylic acid. As I told you, you can test it, the acidity of carboxylic acid using litmus paper. And let's go to another test for acidity, that is sodium hydrogen carbonate test. Here we have sodium bicarbonate to test it. Yes, the brisk effervescence from the test tube, which clearly indicates the presence of acidic group, which is nothing but carboxylic acid. We are going to confirm it in a while. The second test, the confirmatory test for carboxylic acid group, that is ester test. So here we have ethanol and concentrated sulfuric acid. You can add all these reagents by just a simple click. After 10 minutes, I am pouring it to the water. A fruity smell confirms the presence of ester carboxylic acid functional group. Thanks for watching.